Now let's move on to the final topic of the supplementary lessons on differentiation rules, which cover 3.2 and 3.4 of our textbooks. Actually, this topic was buried in some of those exercise sets in our textbook, but I thought these problems were worthy of reconsideration as a separate section, so I'm doing that. Here's the first example. We can find out the derivative of h for x value, appropriate x value, when h is given by something like these. As a matter of fact, we have done this before, so consequently this example is already open here. How do you find out h prime of x? Straight from the definition, h is 5f minus 4g, so using the coefficient rule and addition rule, you can find out the derivative. And then h prime of 2, all I have to do is replace x by 2, replace x by 2. And then what? F prime of 2, that's given. G prime of 2, that's also given. Negative 2 and 7 respectively. So plugging in those values, actually f prime of 2 is negative 2, so this should have been negative 2, excuse me. So 5 times negative 2, that should be negative 10, and negative 8, so this should be what? Negative 38. I'm sorry, obviously I made a mistake here when I talked about this earlier, after the product rule, I think. Luckily I found it and corrected it. Thank you. Alright, that was relatively trivial, and let's move on to a little bit more significant example where we have to use product rule and combine this with product rule. H is given by f and g, so h prime is given by the product rule. F prime of x, g of x plus f of x times g prime of x. Kind of like u prime v plus uv prime. And then all the x values are 2's. So here they are. And then find out what is f prime of 2, what is g of 2, what is f of 2, and what is g prime of 2. And here we go. Negative 2 times 4 plus negative 3 times 7. Let's make sure everything is correct. I made a mistake before, so I'm a little bit worried if they are all the same. Okay, they're all correct. What if we have a quotient? H is f over g. All we have to do is to exploit the quotient rule like this, and then replace all the x's by 2. And then what is f prime of 2? What is g of 2? What is f of 2? And what is g prime of 2? Calculate everything and we have a certain number. No sweat. And then finally, this example, well, the denominator is given as 1 plus g, but mainly this is a quotient rule. Denominator square, u prime v plus uv prime, and then replace all the x's by 2. And then what do we have? Well, this computation, and then put it in calculator, you're gonna get negative 3/2. Not too difficult. Now, if you have to do this to chain rule, that's gonna cause a little bit of confusion actually. Here's an example. When x is given as 1, 2, and 3 respectively, we have f of x, f prime of x, g of x, and g prime of x. For example, here f of 1 is 3. When x is 1, that's my function value. F of 2 is 1. What is f prime of 2? X is 2, function value, that's going to be 5. F prime of 1 will be 4. Say g prime of 3 is 9, and so on. Using all these, we can find out the derivatives of some composite functions, and let's go ahead and do that. So, find out the derivative of u using the chain rule, and that's just straightforward application of the chain rule. And then we want to find out u prime of 1, so replace all the x's by 1, and then here we go. We are doing the computation and we have multiple parentheses, so inside first. What is g of 1? In the table, x value is 1, for that, oh, that's 2. So g of 1 is 2, consequently, that will be replaced by 2, and what do you get? This is 2, so this whole thing is f of 2, as we see over here, f prime of 2, excuse me. Now we are ready. F prime of 2, read it, that's 5. G prime of 1, read it, that's 6. So we are going to get 5 times 6, that's going to be 30. Let's review this just once more. Let's go over to problem B of this problem. Let's see. Straight ahead application of the chain rule gives us v prime is g prime of f times f prime of x, yes. And then replacing all the x's by 1, this is what you're going to get. F of 1, f prime of 1. Now we are doing the computation, even though there is no algebraic equation. How do we do? Order of operation, inside first. We have to find out what is f of 1 from the table. F of 1 is 3. So that f prime of 1 will be replaced by 3. So this whole thing will be g prime of 3. Okay, g prime of 3, what is it? 9. What is f prime of 1? That is 4. So this whole thing will become 9 times 4. That's 36. The other two problems are similar. I'm just using f twice. I'm using g twice. I'm going to leave these two as exercises. And also, I could do the same thing with 3 functions. All I have to do is just apply this chain rule twice. Okay, let's move on to the next class of problems. This time using graphs. So we have a graph of 2 functions. F of x is given as red, g of x is given in blue, and p and q are given as product and quotients respectively, and u and v are given as composite functions. And we have to find out these derivative values. How do you find out? Let's go to the easiest one. So let's go ahead with this one. What is p prime of 2? It's coming from the derivative it's coming from the product rule, f prime g plus fg prime, and then plugging in x equals to 2, I get f prime of 2 times g of 2 plus f of 2 times g prime of 2. So far so good. Now comes the hard part. Inadvertently I just gave away the answer, but okay, let's pretend we don't see that and let's find out. What is f prime of 2 from this picture? X equals to 2, and I'm looking at this point here, and what is the tangent line? That's going to be the horizontal line. So slope of the tangent line will be 0. That's how I get 0 right here. G of 2 is easy. That's the function value, y-coordinate value. So 0 times 2. How about the others? F of 2, that y-coordinate value, that's 3 of course. And finally g prime of 2. I have to find out the slope here, but this is already a line segment, so it's easy to find out. Rise over run is 1/2. So consequently, we end up with 3/2 according to this computation. How about the quotient? Let's concentrate upon x equals 7 this time, right over here. And then let's put everything into quotient rule. And then x equals to 7, so here we go. And let's find out the derivatives and function values for x equals to 7. f prime of 7, what is it? Right over here, slope, that's line segment, so it's just rise over run of this line segment, it's 1/4. G of 7, that's a y-coordinate value, so that's 1, minus f of 7, that's this y-coordinate value, right over here where my mouse is, that's 5, and then g prime of 7 finally, right here, I'm looking at this line segment, and then slope of this tangent line is slope of this line segment, so it's going to be rise over run is negative 2/3, yielding this kind of computation. Well, this kind of computation is not that necessary. I mean, you can stop here if you will. It's not really nice computation anyway. Now let's move on to composite functions. What is u prime of 2? Again, we'll have to use a chain rule. So what is u prime of 2? Prime of x is gonna be u prime of the inner function, excuse me, outer function is f prime times the derivative of outer inner function. Here is the structure of the chain rule, and then what we want to do here is we want to calculate the derivative evaluated at x equals to 2, and here they are. Okay, now that we got everything, let's do the computation. Let's find out inside first. What is g of 2? This y-coordinate value when x equals to 2. That's 2, isn't it? So this whole thing becomes u prime of 2 equals to f prime of 2 times g prime of 2. Now, what is f prime of 2? F prime of 2, that's this point, so this is horizontal tangent, so that's 0. So 0 times, what is g prime of 2? And this is going to be this slope right over here. Not that it really matters. 0 times 1/2, so the answer will become 0. Actually, once you get 0 times something, you're going to see that's going to be 0. Did I do this right? Yes, okay, here it is. I just didn't want to give away the answer, so it is all this writing again. And let's do the same thing to the final problem, v prime of 1. So this time, this is going to be g of f of x. So v prime of x is going to be g prime of f of x times the derivative of inside f prime of x. Consequently, if I want to find out x equals to 1 case, let's replace all the x's by 1, and then let's find out inside first. What is f of 1? X value is 1, y coordinate value is 1, 2, 3, 4, isn't it? So y coordinate is 4 from this point. So what do we get? We got g prime of 4 times f prime of 1. Now what? What is g prime of 4? 1, 2, 3, 4. Right here. What's that derivative? Actually, the derivative doesn't exist here because this is a cusp. Left hand side derivative is this slope. Right hand side derivative is that slope. They are not the same. And then f prime of 1 is going to be slope right here. You don't really have to know that because this value is undefined. Undefined times certain value. This is going to be undefined. kind of tricky because you have to see this point has derivative. Actually, not derivative. This point does not have any derivative.